So first, finding this, we kind of went over this in class, so I think we should be okay with the fact that if this object is spinning around this, then the sum of the forces is equal to mv squared over r, and then the tension is what's keeping it doing that, the tension in the thing. So the tension is equal to mv squared over r. That's how you get the 17.3. Is it horizontal? We also did that in class. We see that the f sub g here is pointing down, and then it's like the 17.3 newtons is pointing that way, and then gravity or the tension will have to lift it up with 1 newton this way. Well, that theta, that angle theta, came out to be around 30 degrees, which is pretty shallow, so we don't have to worry about that. Now the last one, what we had to do in order to find the change, let me make sure the wording is correct. How much farther does the rubber band stretch? So I guess just the change in radius. Yeah, just the change in radius. So if we know the sum of the forces is equal to this, and then tension is kx, so it's kx is equal to mv squared over r. And what we have to remember is that this delta r, this r right here, r is equal to the original length of the spring plus delta x from that. Okay, so if we can find L, then we can find a new delta x. That would work. Because then this would be delta x, and then this r would be L plus delta x. So we can find the original L, and the only unknown would be that. So let me say that again. If we know delta x here, and then k delta x equals mv over L plus delta x, right? Then that lets us know what the stretch for part C is. So this is delta xc. And we can compare delta xc to delta xa, and we'll be fine. So delta xa, we know that tension is equal to Fs. So the tension is equal to Kx, or to K delta x for A. So delta x for A is equal to T over K. And T is 17.3 newtons divided by 90 newtons per meter. So that's going to give us the delta x. So 17.3 divided by 90, that gives us 0.192 meters. That's the stretch. And so L is equal to 0.308 meters. So that's the length of L, that's the length of the original delta x. So from here, since we know L is equal to 0.308 meters, then we can cross multiply and start isolating. So K delta x times L plus delta x is equal to mv squared. So you're going to get some quadratic thingy. So you get like, so this comes out to be 90. I'm just going to put x to make my life easier. And then this is 0.3. I'm going to leave that to make my life easier. Plus x is equal to the mass 0.12 kilograms. So this is 0.12 kilograms times V, which is 9.5 squared. So then we get 27x plus 90x squared minus 10.8 equals 0. So if I go to polysmelt and I put 90, 27, and negative 10.8, we get x is equal to 0.227 meters. We also get a negative value, but that doesn't really make any sense. So 0.227 meters. So that makes no sense.